Good morning, everyone. My name is Stephen Archer from F5. I can't really see you very well because I'm being blinded by the lights. But just out of interest, I wonder how many of you have actually heard of F5? Wow. That's, well, about 3/4 of you, I would guess. OK, so the title of the presentation is What is Ingress Really? So the main aim of this presentation is to answer that question. I'm also going to talk about what F5 are looking to do in the kind of near and medium future, and talk a little bit about F5 cloud services. And yeah, I guess if you've got any questions of us, our booth is just inside the first door there. So please come and see us a little bit later. So first of all, I wanted to share some news. If you hadn't heard, I mean, how many of you had heard that recently, back in May, F5 completed the acquisition of NGINX? And I just wanted to share some of the views of the new combined team, those from the F5 side and those from the NGINX side. And I've actually personally been working pretty closely with a bunch of the NGINX guys over the last 6 months, and we've formed a really fantastic team. So from the F5 side, those of you that know F5, I mean, we have the most comprehensive ADC solution anywhere. And I guess if you're a service provider, we can provide you with, 8-bladed chassis that will handle billions of current connections, handle, multi-terabits per second of traffic. It's a very complex product, very capable, very open architecture, and we can handle huge workloads. But we can only shrink that down so far. So the smallest we currently make that capability available is in the form of a virtual appliance. But the acquisition of NGINX means that we now have a data plane that can run in a container. So the NGINX source code is tiny, less than 2 megabytes in size. So that means that we can go into areas that we previously couldn't. And from the NGINX side, they tell me that they are really, really happy with the cultural fit within F5. And also, they're really, really excited at the extra resources that F5 can bring to NGINX. Now, F5 have also committed to not just maintaining the open source, but we're actually going to increase our efforts in open source. So that is not going to go away. And I think from the NGINX side, they were working on NGINX controller. I think they had a team of around 20 people. And since May, we've moved a comparative team in F5 that were working on a similar controller into the NGINX business unit, and that is now 140 people. So NGINX have really been able to accelerate the things that they wanted to do with controller. And we're going to be delivering the first kind of combined product later this year and early next year. So there's some really, really cool stuff on the way. So back to the title of the presentation, what is Ingress really? And what I wanted to do, I built this presentation after talking with various people at DevOps communities and meetups and conferences like this. And some people, and I'm sure in this audience, many of you will already know what Ingress is, and application Ingress in particular. But many don't have a clear idea of what it is. So what I'm going to do is start at the beginning, explain what it is, and then we'll get a bit more technical after that. And the way I wanted to do it is with an analogy. Now, one thing to say is that application Ingress, or Ingress as a term, has been co-opted by, almost to exclusively mean traffic arriving into a Kubernetes cluster. But it's much, much more than that. So in this analogy, I am a supplier of your company, and I need to deliver some goods to your organization. So in order to do that, the first thing I need to do is to make some inquiries. So I get on the phone, and I phone one of your call centers in order to try and find a precise address for one of your warehouses. So I speak to the person, I get an address of a warehouse, and this data these goods that I want to send is analogous to sending data to an application. The warehouse is analogous to an IP address, and telephoning the call center is analogous to a DNS lookup. So I've got the precise address, so I can now start to pack the goods into crates. So these are data packets, of course. I can load them onto a truck, and I can lock the truck with a padlock. And the padlock is provided kindly by your organization. I don't have the keys, and this is obviously analogous to TLS encryption. So now the truck is ready to roll. So I can plot a route to the warehouse, and this is obviously the equivalent to routing across a data network. But there's a problem with the warehouse. For some reason, it's not available. So I need to go back to the call center to try and find an alternate location. Now, if this was DNS, I would keep phoning the call center, and they would keep giving me the same address. Obviously, we've seen that that address is not available, so this can be a problem with DNS. If the call center was the equivalent of GSLB, or Global Server Load Balancing, then immediately they would be aware that the warehouse is not available. They would be able to give me a different address of a warehouse that was available and had capacity to handle the incoming goods. So that's what happens. We now have an alternate address, so I can get my truck on the road. And when I arrive at the warehouse, which is equivalent of your application IP address, I'm sent to Bay 443. And this is obviously equivalent of a TCP port. And once there, the employees within the warehouse have the keys for the padlock. So they're able to unlock the truck and unpack the crates. Opening the crates, there are smaller packages inside, and these packages have additional address labels addressed to other individuals or buildings within the organization. One of them is addressed to Mr. Baldrick, and he could be seen as an equivalent to a vulnerable web server with access to a database. And he opens his box and finds a free gift inside, a nice pair of Bluetooth headphones with a dongle. And through social engineering, he plugs it into his laptop. And obviously, this is analogous to executing malicious code on your web server. Not a great place to be. So a question would be, would you allow trucks from anywhere in the world, locked trucks, to drive straight into your warehouse without any checks whatsoever? And I mean, I wouldn't. But actually, this is what many organizations and many of our customers are doing. They're allowing encrypted traffic all the way through to their web servers. So when we look at automated deployments, actually the picture is worse, dare I say. Many of the people that we speak to find that trying to automate security is difficult. And therefore, we find a small number of people or customers who are able to do full automation. So I'm talking about CI/CD squared, where we've got automation from the application all the way through to the Ingress, where you've now got your application available and on the internet. The challenge people have with security means that either they miss out that last mile. So within the development teams, automation is working just brilliant, but then they have to open a ticket with an infrastructure team in order to open firewalls and other things. So you're not gaining all the benefits of automation. The other alternative is that actually we just forget about security altogether in the infrastructure, which I obviously think is not a great idea. But it really genuinely does happen. So what could we have done differently? So first of all, we could have checked the routing manifest that came with the lorry. And we could have identified that it came from an unfriendly nation state. And actually, we could just have an embargo and block all traffic from that nation state. And this is equivalent to geo-blocking, quite a simple security technique. We could have checked the credentials of the driver or the registration plate of the lorry. And if we looked on a crime database, we could have seen that those were associated with a previous crime, and we could have blocked on that basis. And that's like an IP reputation database. We could have checked the fingerprints of the driver, and that's kind of like device fingerprinting. And we could have found that that device we've seen performing malicious things previously. Now, when the truck got to the warehouse, what would it have looked like if we'd have implemented a network firewall? Well, I guess it would have been somebody saying, you're not allowed to go to port 442, and you're not allowed to go to, port gate 444, you're only allowed to 443. Now, in this warehouse, 442 and 444 were locked shut anyway, so it didn't really provide much benefit. So in this scenario, a firewall doesn't really do very much. A firewall cannot unlock that truck. It doesn't have the keys, so it cannot inspect the goods. It can only make sure we go to bay 444. So what about WAF? If we put a WAF in this scenario, it would be kind of like creating a secure zone at bay 444 where we unpack all the crates. So a WAF has a capability of obviously decrypting the traffic. So we can now start to unpack the crates, have a look what's inside. And specifically talking about F5's WAF, we have a normalization engine, and it's unique to F5. And what this does, it does multiple passes of decoding. So in this analogy, packing and unpacking smaller and smaller boxes, kind of like a Russian doll. And only when we get to the smallest doll, which is the raw HTTP, do we then start to apply our signatures, which means we have a much smaller set of signatures. So you may look at other WAF technology and find that they've got more signatures than we have. But this is the problem. For one attack, they'll have a signature for the big doll, the next doll, the next doll, and then they kind of run out of capacity. Whereas we can keep going. We can unwrap these dolls, and we only apply the signature on the core HTTP underneath. And actually, you can choose how many dolls you'll open. And if we reach that limit, so if you set 4, for example, we might do 4 decoding rounds. And at the end of that, if we're still faced with another doll that you can open, another round of encoding is needed, we'll just determine that that's an attack, and we will drop the traffic. OK, so if we look at other things we could have done, if we'd have sent all of these parcels to a mailroom, that's kind of analogous to an API gateway, where additional inspection of the addresses, the HTTP headers, is done. So in the mailroom, they may have certain addresses that are not permitted, so they'll bin or hopefully recycle whatever they find. And letters to the CEO would probably be opened by a PA and given another level of inspection. So there are lots of things that we could have done differently or better. So hopefully I've kind of explained that Ingress is more than just packets arriving in a Kubernetes cluster. Actually, Ingress or application Ingress has a whole number of infrastructure components. So we've talked about DNS, GSLB, routing, networking, WAF. But there's other things, DDoS mitigation, and things like health checking, circuit breaking, A/B testing. service discovery, and so on and so on and so on. There's lots of functions that are included in this. All of these functions are performed by an application delivery controller. Ergo, Ingress is actually application delivery. So what I want to do now is, I meant to say actually, no. So customers have many components that form their Ingress data path. And typically we're talking about, I don't know, 7 to 9 is kind of typical. These are the common ones listed here. What you'll find is that you talk to 10 customers, and they'll have 10 different sets of services with different vendors. No two customers really are alike. And it's a complex picture. And I'm sure you all have a similar picture to this in your environment. And it gets worse. Many customers will have different sets of vendors for different application architectures. So for the monolithic applications, they may have a different set of vendors in place. Different teams are making decisions and buying different vendors for microservices. And then you move to public cloud, and you've got another set again. And what you tend to find is that these individual vendors, organizations tend to create silos around them. So you have multiple silos along this data path. And then it gets even more complex because, if you've got multiple environments, then you may have even more silos. And each of these vendors have their own management interfaces, their own orchestration frameworks. And it becomes really complex to be able to manage. Each team in each silo are comfortable with their interface. Other teams maybe not. And it means that when customers want to do automation, they need to learn all of these different capabilities and the peculiarities of each of them. And it's left to the customer really to try and stitch them all together, which we think is a big problem. And I'm sure you've all been in a position similar to this. I mean, I've been at F5 for 9 years, and previously when I was a consultant, I was on calls till goodness knows what time at night, trying to diagnose problems. And because F5 is always in the data path, we're always involved in those calls. I like to say, rarely are we the cause of the problem. I guess I would say that, but I like to think that's true. Trying to diagnose which of these solutions is the cause of the problem is really hard work. With all these silos, blaming each other, not necessarily being as helpful as they might be, it can be really tricky. So this is the power of the combined F5 and Nginx. You can see that we've got a presence in every step between the code deployed on the application server all the way through to the customer. With F5 technology, we're actually reaching into the browser even with JavaScript. So we literally from end to end. We are the only vendor that has this end-to-end capability. So this is what it kind of looks like today. You can see we've got some Nginx stuff here, big IP stuff here, Nginx at the end. But between us, we can be deployed in any architecture. And actually, we've got many different consumption models. So whether you want to buy your own license or pay hourly or whatever you want to do, there's a solution for you. So what we're doing next, and we've already started on this, is that we're going to start stitching together the control planes of all of our products, because at the moment, they're kind of separate. And one of the things that we're working on is Project Overwatch. So this is providing a consistent single pane of glass to be able to manage all of your devices. components and services, we're also going to be adding in capabilities to add other vendors into that solution, and that's delivered software as a service in the cloud. So that's one of F5 Cloud Services' new services. It's available today in preview. We've also got things like intelligent threat services. So this is a capability that's being built by our security team. There's lots of capabilities there, and we'll talk a little bit about them later. And of course, we've got, future services. So we're going to expand on this code to customer story. So we're going to be adding in new capabilities in at either end. We're working on many of them already. Some of these are partially available already, but we're, again, going to build on those. And I suppose once we've got a single coherent platform for management and visibility, the next step is to start creating insights from that, building intelligence, centralized intelligence that can really provide business benefits out of this fantastic visibility that we have of your application end to end. So I was probably a little bit chicken. I was going to do a live demo, and I thought, actually, do you know what? I'm just going to build some slides that show the demo, just in case anything went wrong. So why do we need Ingress security? Well, I mean, I'm pretty sure you all know better than I do that building applications and building security into applications is not a perfect science. There are things that you can do. Obviously, having a fantastic engineer is probably the best of them, somebody who really understands security. But there are tools out there, SaaS tools and dependency libraries and stuff like that, that will allow you to identify some of the more obvious kind of vulnerabilities. There are server-side security tools that you can deploy, but again, none of them are perfect. I talk to customers who tell me that in order to try and detect all of their vulnerabilities at the code level, they're using half a dozen different tools because no one tool is perfect and can cover all bases, and actually using them all together is pretty much unworkable. Now, I'd be interested to hear your views on this. I'm not going to ask you now, but if you disagree with me and you think that actually it's possible to have excellent security through the build process, then please come and tell me, because I don't want to be at the next conference telling people lies. So I'm kind of regurgitating what I've heard from our customers. So how can you automate security? There are a number of things that you can do, and the first of those, the thing on the left, is negative security. And on the right, it's intelligent security. And these are the only two ways I think that it's possible to build security into the ingress, into the data path. So negative security is signatures. But if you want to automate a solution that uses negative security and signatures, then those signatures need to be highly accurate. At F5, we have all of our signatures are categorized in terms of their accuracy. So you want to use our high accuracy signatures. We also have a service called Threat Campaigns, which allows us to bring in very high accuracy signatures on demand and in reaction to what kind of attacks are actually ongoing in the wild today. And as those attacks modify and change, then we'll take those signatures out and replace them with different ones. So the trick with negative security is the more accurate your signature, the more computationally expensive it is. So with threat campaigns, we have very high accuracy, but we have a low number of them, and they're targeted. So that's really useful. We also have bot signatures. So bot signatures are again, really useful. A lot of the bots are quite helpful in that they provide a user agent, so they're easy to identify. Bot signatures, very, very low false positive. Others that try and emulate a browser often fail to get the HTTP headers in the right order. And then some try and pretend to be good bots, but aren't. So we can do a reverse lookup on the source address of that bot and determine whether it really is a good bot or not. So there's lots of things we can do with negative security. But I think far better is to add some intelligence into the system. And this is something that we're working on at F5. There's a lot of work going on centralized analytics, so centralized an understanding and fingerprinting of every single device on Earth. That's the goal. So that's underway. But today, what can we do? Well, positive security for an application is a much better place than negative security. So I'm going to show you a little example of how our declarative API for our advanced WAF can help with that. And of course, today we've got very limited time, so there's only so much we can talk about. Actually, the most difficult thing has been actually what do we have to leave out today. So back to this slide that we saw earlier, we're going to kind of focus in on application security. And I hope this is visible to you all. It kind of looks OK to me. So what this is a screenshot of my CI/CD pipeline in GitLab. I'm sure yours, in reality, is going to be much more complex than this, but it really just kind of proves a point and shows that adding positive security it actually can be pretty simple. So we've got some dependency scanning, SAST, we're building and deploying to staging. Then deploy the WAF policy onto the WAF in line in front of the application in the staging environment. So this is the WAF policy. It's JSON, it's declarative. So we just post this to the WAF, and it will deploy this policy. So we define the policy, give it a name. We define the template that we want to use. So we have a number of templates built in on the platform, but you can create your own with your own standards. But this is a good suggestion, rapid deployment. The enforcement mode, blocking or transparent. You specify the server technologies that you're using for your application. In this case, we've got MySQL and Unix, Linux. And then we've got blocking settings. So what I've got in this case is that I'm going to block on file types. So we have a default list of file types that we deem as OK. You know, pretty safe things that you would expect for a web application. And because obviously the screen is not long enough, this is a continuation. So signature settings. So I'm not going to put my signatures into staging. I'm putting them straight into production, so to speak. And then I'm going to, for my policy builder, I want to learn from you know, testers, not from bots. And then I've got a couple of webhooks set up. So we now have the ability to send webhooks. So this one is going to be triggered every time we apply a WAF policy. And this one every time we receive an illegal request. So in my lab, this goes to Slack. But you can obviously use this to trigger your pipeline. And then we've got a modification section. And because this is a base policy, there are no modifications yet. So those parts of defining the base policy and the adjustments. So the adjustments, I mean things like making it application specific, so like the server technologies, the blocking settings, and so on. And then here we're defining the policy modifications, of which there are none yet. So this is my pipeline. So I've now deployed my WAF policy, and I've got some testing, some functional testing. So again, in my lab, it's just a few curls to pull different files down. I'm sure yours are way more sophisticated than that. But in this case, my requests were rejected, actually blocked by the WAF. So next, my pipeline reaches out to the WAF, sends a curl, and asks for an export of the suggestions. So suggestions in our WAF are what the WAF provides you when you're in learning mode. So as you're in your test environment and the WAF policy blocks something, it will give you a suggestion and say, well, actually, if you meant that to get through to your application, you need to disable this or this or this. So they are suggestions to help you loosen the policy to fit the application. So when you send a curl to the API, this is the response that you get. In there is the suggestions, and we have entity changes that it's recommending. And in this case, we've got 2 of them. I haven't got space for the rest of that down there, but there are 2 in this case. And that section, we can just pull that out, and we can merge that into the policy. So you can see in the modifications section, I've literally just merged those straight in there. And I can repost this, because it's declarative, back to the WAF, and then rerun the pipeline, and second time round, it's now successful. So I've deployed a policy, I've run some test traffic, the WAF told me what I needed to do to make it better, I fixed it, I rerun it, and now everything is working. So now I create my production tag, and then I can deploy Boom to production. Then I can do my DAST testing, you can get your pen testers in, and you're on the road. So hopefully that all kind of makes sense. Pretty simple example, but I just wanted to explain how easy it can be. So don't let anybody tell you that automating security in the Ingress path is difficult. So just a quick couple of minutes on F5 Cloud Services. So this is the mission, the objective, I should say. Cloud-native software as a service solutions for enhanced application delivery, security, and insights. So what we're doing is we're building a whole set of new services and platforms in AWS, in Azure, other clouds to follow. So some of those, for example, we've got global server load balancing as a service, authoritative DNS. We've got Overwatch that I mentioned earlier. And Essential App Protect is kind of like a subset of WAF features that are available as a service in the cloud. And when you decide to purchase one of these services, you log into the portal, you purchase the service, and we deploy containerized instances of our technology in the region that you want to deploy in. So for AWS, for example, if you want to deploy in EU West 2, you specify that, and we will deploy your service there, and we'll connect with your environment. So with that, hopefully I've answered my own question, which is what was Ingress? We talked a little bit about what F5 and Nginx are doing together and what we're doing in the future. And if you've got any questions, well, we're just through the door over there, so please come and say hello. Come and tell me I'm wrong if anything I said didn't make sense to you. And of course, yeah, any questions, come and see us. Thank you very much. Right. Questions? Sorry, I should have said, I thought we were running late. So yeah, if you've got questions.
Yeah, one quick question. Could you provide perhaps 1 or 2 specific actionable takeaways for your talk that would benefit attendees regardless of if they buy your product?
Actionable takeaways. So I honestly think the biggest challenge we have as a vendor is that we're trying to build solutions that will allow you to break down those barriers between the silos in organizations. So, DevSecOps, I don't know, most organizations, DevSecOps, they're not combined. And that's really my suggestion really is that, we can build the tools, but you guys need to build the organization that can leverage them. So we have all these automation capabilities. We've got fantastic capabilities, but it's getting the development people talking to the guys that actually probably own the silo, that own F5 in your environment. So that would be the key takeaway. Go and talk to them, find out who they are, try and smash down those barriers and get automating. Because once you've done that, it's easy. Does that answer the question?
No, I don't believe so. But thank you anyway.
Oh, ask it again.
Based on your experiences, what can someone do, some effective practical thing someone can do that's not buy your product? Like maybe some insights don't worry about it.
I was going to say, you're not going to get me to say, don't buy our product. Don't buy our product. No, do buy a product. Any other questions? No, we're good.
Okay,
Thank you
very much. As we've got 20-minute breaks.